Dear students, in the previous session of this chapter, trigonometric function, I had derived a formula L is equal to r theta, where L stands for the length of the arc and r being the radius and theta is the angle subtended at the center by the arc. So, but theta has to be measured in radians. So, after deriving that one, we had worked out some problems. Now, in today's session, I had told in the previous session that I will be deriving this one. It is the area of the sector of a circle. Of course, this formula we will be using in calculus. So, I am teaching now because it is connected with this particular topic. What do you mean by the sector of a circle? See, I have drawn a circle there and with O being the center and R is I have taken R as the radius of that one, and then I have taken 2 points P and Q on the circle such that the angle POQ is equal to theta radian. I have measured the angle in radian. So, the shaded portion there is known as the sector POQ. So, that part, it is a part of the circle. Sector means it is a part of the circle. I am interested in finding the area of the sector of the circle here. So, first we have to explain always. Consider a circle with O as center and R as radius. O as the center and R as the radius. R as the radius. Okay. Next is we have taken 2 points. First, always whenever you do some derivation, see that if the derivation needs a diagram, first write the figure and then explain the figure. So, consider a circle with O as center, R as radius. Take 2 points P and Q on the circle such that angle POQ is equal to theta radian. Theta radian. Now, we have to calculate the area of the sector POQ. So, which sector? The shaded portion is called as the sector, that is sector POQ here. Now, let me take the area of that one. Let A be the area of the sector, Now, in the previous 2 derivations which I did in the earlier sessions, one was pi radian equal to 180 degrees. There also I argued like this: if the length of the arc is more, the angle subtended at the center would be more. If it is less, the angle would be less. In other words, the length of the arc would be proportional to the angle subtended at the center. The same argument holds good here also. Suppose I take the points here, P if it is shifted here or Q shifted there, what happens to the angle here? Angle would be increasing. Angle would be increasing, and what happens to the area here? Angle increases and area will also be increasing. That is, when the area increases, angle subtended at the center will also be more. That is, angle increases, area increases. Angle decreases, area decreases. That means that area of the sector depends upon the angle at the center. Our angle at the center is depending upon the area. They are proportional. So, here I compare 2 areas here. Area of the sector POQ and also area of the whole circle. That is, what is the formula to find the area of a circle? It is pi r square. So, using that one we can compare, we know that you write area of the circle divided by area of the sector, Now, here the angle at the center, and here what is the angle? You can write the angle POQ, because the sector, of course you can write here the sector POQ. When the angle, no, I use that notation. Now, area of the circle, you know that it is equal to pi r square, whole thing divided by area of the sector. I have denoted it to be equal to A. Now, angle at the center means the full angle you have to consider, which is equal to 360 degrees. I am using here radian, therefore you can write it as 2 pi radian. This conversion I have taught you already, and angle POQ is equal to theta. Now, you can see that pi can be cancelled here. Now, on cross multiplication, because we are interested in finding the area here. Therefore, A would be A, take A here and theta goes to this one and 2 comes here. So, it becomes half of r square into theta. So, this is the formula which gives us the area of the sector of a circle, that is half into r square into theta, where r is the radius of the circle, theta being the angle subtended at the center of that particular sector here. So, theta should be measured always in radian. So, this is the formula. Of course, in this chapter this may not be asked here, but this is important in the case of when you discuss about the calculus. There will become, when we derive a formula there, some limit we have called as a limit. We will come to that later in the coming sessions. In there we make use of this one because there we consider the area of a sector. For that purpose it is usually taught here. Now, I will work out one problem here connected with this one, that is given the data, the radius as well as the angle, how to find the area here. So, if in a particular the radius is equal to 2 centimeters, if the angle theta is equal to 45 degrees, find the area of the sector. So, if in a sector of a circle whose radius is equal to 2 centimeter and the angle at the subtended at the center of the sector is 45 degrees, find the area of the sector. Now, 45 degrees means we have done this already, it is equal to pi by 4 radian. Be familiar with that one. 30 degree pi by 6, 45 pi by 4, 60 degree pi by 3 and 90 degree pi by 2, because these are all the standard values will be coming across rather often. So, if you remember, each time you need not write 45 into pi by 180, it is not necessary, directly you could write. Now, consider the formula A is equal to half into r square into theta. Let me write the value. Half into r square means 2 square into theta is pi by 4. Now, 2 square is 4 and 4 they get cancelled. This is equal to pi by 2. So, area of the sector, area always is written in square terms, that is square centimeter, because the unit that is given is centimeter here. So, it is so many pi by 2 square centimeter. You can keep it in not write for pi as 22 by 7, you can keep the answer as it is, because you know that when we write the area of the circle we write it as pi r square. So, that pi can be used here also when you get the area of the sector of a circle. Okay. Now, the next thing, of course, I had mentioned in the previous session itself that I will be teaching you about the trigonometric. This part, this radian measure and all, it is in the first year PUC portion only. And now what I am teaching, I am starting the trigonometric part. So, only the measurement of an angle I had considered in the earlier 2 sessions, and that L is equal to r theta is connected with the measurement of the angle. So, for a 1 mark question, the radian to degree, degree to radian can be expected. The definition of radian for a 1 mark question you can expect, and L equal to r theta, given any 2 quantities you can get the other one. L is given, L and R are given, theta like that. We have done problems of all the types in the previous session. Now, area of a sector, this formula will be utilized further. By chance a problem is given on that one, you can solve this one. It can be expected just for a 1 mark question. Now, I am starting the trigonometric ratios here, and of course you have already studied about the definitions of the trigonometric ratios. I am just recalling that one, that is whatever you already learnt here, I am just reminding you about the definition. So, now the topic now is trigonometric ratios. Trigonometric ratios. When it was taught in the lower classes for you, you might have learnt about how this particular branch was developed and all. Actually, trigonometry means it is the measurement of the 3 angles of a triangle. So, when this particular branch was developed, The main idea was to find the heights of the tall towers or distance between any two points, any two objects like that. That was the main purpose of developing this particular branch of mathematics. But afterwards, no, it is used in not only in the other branches of mathematics, other branches of science also. It is quite an important and interesting branch. So, in this one, first we define the trigonometric ratios. Of course, when we define it, we refer to a right angle triangle. With reference to a right angle triangle, we define the 6 trigonometrical ratios. Afterwards, in the coming sessions, we will be extending to the other value. Right angle triangle means the value would be, it would be an acute angle we will be considering. That can be extended to higher values of the angle also. So, let me consider a right angle triangle. Right angle triangle, say ABC. So, the angle B is equal to 90 degree. So, consider a right angle triangle ABC, right angle being at the point B or at the vertex B. Now, both A and C are acute angles here. You can take any one of them, either this or this. Usually we take the base angle because it is easy for us to understand the concept. So, let me denote this as theta. Theta already I am using in the earlier sessions. Theta is a Greek alphabet, Theta. That is how generally we take the angle to be theta here. Now, for this angle theta, now this is the opposite side. This is the opposite side, and for this one it is the adjacent side. That is why I said that I am considering this. Suppose you have taken this as theta, this becomes the opposite side and this becomes the adjacent. Adjacent means which is by the side of that one, and opposite means which is opposite to that one. Of course, this is common, it would be the hypotenuse, isn't it? It is the hypotenuse. Now, here with reference to the angle theta, we define 6 trigonometrical ratios. What is the first ratio? First ratio being sine theta. We read it as sine theta. But when you write it, no, we take only the first 3 alphabet, that is sin theta. Don't read it as sin theta. It has to be read as sin theta. It has to be pronounced as sin theta only. But we write only the first 3 alphabet. And here, don't write it as A, B, B, C, A, C like that. It is always better to remember in terms of the sides here. In other words, it is opposite side divided by the hypotenuse. Okay. Of course, in this triangle, it is AB by AC. Don't by heart like that, because the ABC may be in other places, or instead of ABC we may have PQR. So, that is confusing. Always remember in terms of the sides of the triangle. So, sine of theta means whatever may be the triangle we are considering, that is always opposite side divided by the hypotenuse. Next is cosine. It is CO is added before. Okay, that is prefix. So, cosine, we take the first 3 alphabets, so we read it as cos theta. The word actually is cosine, sine and cosine. Okay, so here this is adjacent side. This is adjacent side over the hypotenuse. This is adjacent side over the hypotenuse. So, in this triangle, it is BC divided by AC. Now, come to the third one, tangent. Tangent of theta. Tangent of theta, the procedure is we take 3 alphabet. So, we read it as tan theta. The word is actually tangent of theta. And how do you define this one? It is opposite side divided by the adjacent side. The opposite over the adjacent side. So, apart from this one, I am going to define 3 more ratios. The next one, the fourth one is taken as cosecant theta. Cosecant. It has to be read as cosecant theta. Usually our practice is to take the first 3 alphabets. If you take first 3, that becomes cos, which is already there. So, only for this particular ratio, we take the first 5 alphabets. Don't read it as cosec. Some pronounce it as cosec. It is rather odd. Better you read it as cosecant. You pronounce it as cosecant theta. And how do you define this one? It is hypotenuse divided by the opposite side. Hypotenuse divided by the opposite side. Come to the next one, that is cosecant, and it is secant. That co is taken out and secant, here also secant of theta. We take the first three letters and write it as secant theta. Read it as secant theta, write it as SEC theta. How it is defined is, it is hypotenuse over the adjacent side. And finally, we have cotangent. Cotangent theta, that is, when you take the three letters here, it becomes cot theta. Cot theta, how do you define? It is the adjacent side over the opposite side. Now, these are the 6 basic trigonometric ratios which we define in this particular way. So, whatever may be the triangle we are considering, generally you remember sin theta means opposite over the hypotenuse, cos theta adjacent over the hypotenuse, tan theta opposite over the adjacent side, and cosecant theta is hypotenuse over the opposite side, and secant theta hypotenuse over the adjacent side, and cotangent or cot theta is adjacent over the opposite side. So, this is how we define the 6 trigonometric ratios. Okay. Now, when we observe these ratios, when we observe these 6 trigonometric ratios, we get some more information. What is that information? Look here. Sin theta we have defined as opposite divided by hypotenuse, correct? Come to cosecant theta, it is hypotenuse divided by the opposite side. Here it is, if you refer to the figure, AB by AC, here it is AC by AB. If you multiply them, that is, you observe that opposite or hypotenuse, and hypotenuse for the opposite means we call it as a reciprocal of each other. That is, sin theta is 1 by cosecant theta, or cosecant theta is 1 by sin theta. We call that a pair of reciprocal ratios. One is the reciprocal. What do you mean by reciprocal? The numerator, denominator, they are interchanged. Interchange means numerator becomes a denominator, denominator becomes numerator. We call it as a reciprocal. So, sin theta and cosecant theta, it's a one pair of reciprocal ratios. Now, come to the next one, cos theta. It is adjacent over the hypotenuse, and how is secant theta defined? It is hypotenuse over the adjacent side. Again, this is the second pair of reciprocal ratios. You can write cos theta as 1 by secant theta, and secant theta can be written as 1 by cos theta, isn't it? Similarly, you can consider the tan theta and cot theta. It is opposite or adjacent, there it is adjacent over the opposite side. Therefore, by the definition, basic definition of the trigonometric ratios, we have seen that there are 6 ratios and they become 3 pairs of reciprocal ratios. That is, sin theta is 1 by cosecant theta. Similarly, and also you can write cosecant theta as 1 by sin theta, as 1 by sin theta. Suppose you take the product of this one, that is sin theta into cosecant theta, what you get here? The product is 1. So, this whenever you come across the product like this, you can write the value 1. But remember, both of them should be of the same power, same index. Suppose you are having sin theta and cosecant square theta, you can't write it as 1. It has to be sin theta into cosecant, or sin square into cosecant square. Like this, they have to be of the same power, same degree, same index should be there. Similarly, you can consider cos theta into secant theta is also 1, and also tan theta into cot theta is equal to 1. So, tan theta could be written as 1 by cot theta and vice versa. So, these 3 pairs, sin and cosecant one pair, cos and secant another pair, tan and cot, it's a third pair of the reciprocal ratio. So, this is one information we get by considering the definition of this one. And another information here itself I am considering. See, sin theta, as you know, is hypotenuse over the opposite side. And what is cos theta? It is, sin theta is opposite over the hypotenuse. It is adjacent over the hypotenuse, isn't it? So, sin theta is opposite over the hypotenuse and cos theta is adjacent over the hypotenuse. Suppose you divide one by the other. If you divide one by the other, you can see hypotenuse, hypotenuse, they get cancelled. What is remaining? It is opposite over adjacent side. And what is this one? It is nothing but tan theta, isn't it? By considering the definition of tan theta, how did you define that one? It is opposite over the adjacent side. So, that is one more information we get here. Tan theta can be expressed as sin theta by cos theta. Okay. So, by the definition, one information we got was there are 6 ratios here. There are 3 pairs of reciprocal ratios: sin theta, cosecant theta, cos theta, secant theta, tan theta and cot theta. That is one information. The other information is tan theta can be expressed as sin theta by cos theta, because considering this one, hypotenuse get cancelled and it is opposite over the adjacent side. So, it is tan theta by sin theta cos theta. And similarly, you can write cot theta as cos theta divided by sin theta. So, wherever you are having tan theta, it can be expressed like this. Suppose you come across sin theta by cos theta, you can write it as tan theta. Same thing holds good here. So, because of the definition of the trigonometric ratios, we got these 2 information. One is there are 3 pairs of reciprocal ratios. That is one information. There are 3 pairs of reciprocal ratios: sin, cosecant, tan, cot, cos and secant. That is one information. And the next one is tan theta is actually sin theta by cos theta is equal to tan theta. Similarly, cot theta is equal to cos theta by sin theta. Of course, all this information are already familiar to you. Still, I am recalling everything because we should have the basic knowledge here. Basic knowledge about the trigonometric ratios and this 2 extra information what I gave just now, because of the definition of the trigonometric ratios. They are important. We will be coming across rather often in working out the problems. This is one thing I wanted to revise. The next one is identities. This is also a revision for you. Trigonometric identities. Actually, all these things, identities can also be derived, but when it was taught now, it was usually a 2-mark question. Because you are familiar with identities also, I am not doing any derivation here. I am just giving the identities. There are 3 basic identities of trigonometry. The first one being sin square theta plus cos square theta. Sin square theta plus cos square theta is equal to 1. Remember, this theta should be same. It's sin square 45 plus cos square 45, sin square 90 plus cos square 90, like that. You cannot have sin square 45 plus cos square 95. You cannot add and write it as 1 because they are square terms. The angle theta should be same here. So, sin square theta plus cos square theta is equal to 1 here. Now, from this one, it can be written in 2 different ways. One is, when you retain cos square theta on one side, it can be written as 1 minus sin square theta. Similarly, sin square theta can be written as 1 minus cos square theta. All these things you have to remember because these are all the basic information about trigonometry. So, when you learn more about trigonometry, all this information somewhere or the other we will be using them. So, each identity can be expressed in 2 different ways. So, here cos square theta can be written 1 minus sin square theta. Suppose you come across 1 minus sin square theta, you can write it as cos square theta. Similarly, if sin square theta is there, it can be written also as 1 minus cos square theta. Now, take the second identity. It is 1 plus tan square theta is equal to secant square theta. Now, 1 plus tan square theta equal to secant square theta. Even this can be written in two different ways. One is retain tan square theta, then one is shifted to the other side. So tan square theta could be written as secant square theta minus 1. Or keeping 1 there as it is, you can write secant square theta minus tan square theta would be equal to 1. Like this, the second identity also can be expressed in two different ways. Come to the third one. It is 1 plus cot square theta. Some write it as cot square theta plus 1. Both are correct. It is cosecant square theta. Here also it can be expressed in two different ways. Cosecant square theta minus 1 is equal to cot square theta, and cosecant square theta minus cot square theta is equal to 1. So, each trigonometric identity can be expressed in two different ways. Just interchanging the terms, value remains the same, we are interchanging the terms and we can write in two different ways. In whatever form we want, we can get the we can write it and I can do the simplification. This is the second information you have learned in the lower classes. So, first one was the definition of the trigonometric ratios. Now, the trigonometric identities, three basic identities. Now, because in first year PUC actual portion, you will be studying more about these things. So, to study about that one, you have to have a very good knowledge about this one. So, when I gave the identity, when I defined the trigonometric ratios, I had not given any value for theta. In general, I had considered the angle theta. Now, suppose a particular value is given to theta. They are called as standard values. At present, with the knowledge of this knowledge, we can discuss only about an acute angle, that is the angle lying between 0 degree and 90 degree. So, even for that also we can draw a triangle and do the derivation. The derivation you need not bother here because it is already done in the lower classes. So, here I gave you only the values. I am going to give you the values of the trigonometric ratios of the standard angles. What are the standard angles? 0 degree, 30 degree, 45 degree, 60 degree and 90 degrees. Of course, 15 degree, 75 they are also considered standard angles, but at present we cannot calculate that one. In the incoming sessions, now when you learn about the compound angle formulae, you can calculate the values of the 15 degrees as well as 75 degrees. The other values, what I told just now, 0 to 90, the acute angles now, whose values you are already familiar, which I am going to give you in the form of a table. So, using that one, you can work out some problems. So, here we write the trigonometric ratios. Trigonometric ratios of standard angles, standard angles. Now, here usually we express them in the tabular column. Now, I am not considering all the ratios here, only the first three I am considering, that is sin, cos and tan. And the remaining, because the other three are the reciprocal ratios, you can take the value in the reciprocal, you can take the reciprocal value of that one. So, here it is sin, cos and tan. Okay. So, here of course, I am giving in degree measurement only. It can be, you can write in radian measure also. It is 30 degrees, 45 degrees, 60 degrees and it is 90 degree. If you write in the radian measure, it is pi by 6, pi by 4, this is pi by 3 and this is pi by 2. So, I have told you that usually when you go to higher classes, the angle is expressed in radian measure. So, you should be familiar with the equivalent radian measure also. Now, sin 0 is 0, sin 30 is 1 by 2, sin 45 is 1 by root 2 and this is sin 60 is root 3 by 2, sin 90 is 1. Similarly, cos 0 is 1 and cos 30 is root 3 by 2 and this is 1 by root 2. this is half and this is 0. Here tan 0, 0, tan it is 1 by root 3, this is 1 and this is root 3. Actually this is not defined. I am telling you why it is not defined. Look here, just now I told you that tan theta could be obtained by dividing sin by cos, that is tan theta is equal to sin theta by cos theta. Come to this particular value. Sin theta is, sin 90 is 1, cos 90 is 0. So sin theta by cos theta means 1 by 0, that is 0 comes in the denominator position, and you know very well that division by 0 is not defined. Therefore, we write not defined, but whenever we come across 0 in the denominator position, we denote it as infinity. Remember always, infinity is not a number. It is only a notation for a very huge quantity. Even in talking to one person, we say it is infinitely big. We use that word. What do you mean by that one? It is a very big quantity. So infinite means it is a huge quantity, not exactly a particular number here. So it is not defined. So whenever we come across 0 in the denominator position, we usually take it as infinity. Okay. So that is infinite in the positive side. So plus infinity we write. So these are called as the standard values. Observe, I have taken the angles. All of them are acute, 0 to 90. Of course, 90 is a right angle. So I have taken in the angles in the first quadrant, 0 to 90. These are called as the standard values. And again, these are very important. Very important means when you consider the angles more than 90, an obtuse angle, reflex angle, all of them, however big an angle may be, however small an angle may be, all of them could be expressed in terms of these angles, that is 30, 45, 60. That is why these are very important. That is what you are going to study in the coming sessions. Now that is when the angle is more than 90, how to find the value of the trigonometric ratios. For that there are some rules here. I am going to teach you about those rules in the coming sessions. Therefore, any angle, I told you just now, however big or however small, it can be converted to any one of these one by some rules which you are going to study in the coming sessions. Now that is why these are very important. Remember, sin 0, 0, sin 30 half, sin 45 1 by root 2, sin 60 root 3 by 2, sin 90 is 1. Similarly, cos 0 is 1, cos 30 root 3 by 2, cos 45 1 by root 2, cos 60 1 by 2, cos 90 0. And tan 0, 0, tan 90 1 by root 3, tan 45 1, tan 60 root 3 and tan 90 not defined, you can denote it by infinity. So these are the values you have to remember very well, they are very important. Now that is why equivalent radian measure also I have written, because in the problems that I am going to give you, I am giving the angle not in degrees but in radian measure. So you have to know the equivalent radian measure also. Now I am going to prove certain result where I make use of these standard values. First problem, prove that you have to prove this result. Prove that 3 times sine of pi by 6, 3 times sine of pi by 6 into secant of pi by 3, sine of pi by 6 secant pi by 3 minus 4 times sine of again pi by 6 into cot of pi by 4. Cot of pi by 4 is equal to 1. So we do not have any ratio on the right hand side, it is a number. Look here in the table, usually the table is written like this only, the only first 3 ratios are considered. You can write the remaining 3 ratios yourself. How do you write that one? You know that cosecant is the reciprocal of sine, isn't it? So you can extend this one and write the values here. Like suppose I take here cosecant. If you can to remember all of them may be difficult. That is why we usually write the first 3. If you remember this one, you can take the reciprocal. Now cosecant 0, here you know that cosecant theta is 1 by sin theta. That is 1 by 0 means you have to write not defined, or you can use the notation infinity. Similarly, cosecant 30, 1 by 2, the reciprocal is 2, and here reciprocal of this one is root 2, and there it becomes 2 by root 3, and this would be equal to 1. Reciprocal 1 is 1 only. Similarly, secant you can take. Secant is the reciprocal of cos. So, it is cos 0 is 1 means secant 0 will also be 1 by 1, and then it is the reciprocal of this one, 2 by root 3, root 2, 2, and here again we have to write not defined because here it becomes 1 by 0. Finally, you can take the cot ratio also. Cot means here it is 1 by 0, again it is not defined, and this is root 3, this is 1, this is 1 by root 3, and here it becomes 0. Okay. So, this is how we write the values here, 0 by 1, that becomes 0. Usually we write only the first 3, this will not be written. Now, why I am telling about this one? In this problem I have taken secant of pi by 3, which was not in the table. Now, let me write the value. Since we are proving, start with the left hand side. First write the actual values. Sin pi by 6. Pi by 6 means it is 30 degree. Therefore, sin 30, what is the value? 1 by 2 into secant 60. Pi by 3 means 60. Now, here cos 60 is 1 by 2. Therefore, secant 60 is the reciprocal of that one. Therefore, you can write it as 2 minus 4 into, again same number I am having, it is 1 by 2, and what is cot 45? See, tan 45 is 1, cot 45, the reciprocal is also equal to 1. So, if you simplify, you should get the right hand side. Now, 2 and 2 are cancelled, 2 1s are, 2 2s are, you can cancel. What is remaining? 3 minus 2, that would be equal to 1, you write it as the right hand side. So, this is how we have to write. So, in all the problems, I am giving you the angle in the radian measure. Therefore, you have to be familiar with the equivalent radian measure. Now, let me move on to the next problem. Next problem is sin square pi by 6. Sin square, you have to prove this result also. Sin square pi by 6 plus cos square pi by 3, cos square pi by 3 minus tan square pi by 4, tan square pi by 4 should be equal to minus half, should be equal to minus half. Now, look here, in the previous problem we had the degree sin pi by 6 secant like that. Here we are having the square terms, isn't it? So, same thing, the values have to be squared. First take sin pi by 6. Pi by 6 means 30 degree, that is half the whole square. Okay, plus cos pi by 3. Cos pi by 3 means cos 60. What is the value? That is also equal to 1 by 2. So, it is 1 by 2 the whole square minus tan 45. Tan pi by 4 is 1 square. Now, write it. 1 by 2 whole square means 1 by 4. 1 by 2 whole square means 1 by 4 minus 1. Now, these numbers are quite simple. Without taking the LCM you can do, isn't it? Look here, 1 by 4 plus 1 by 4, 1/4 and 1/4. When you add, what do you get? Half, isn't it? And half plus half minus 1 is minus half. It's a very basic calculation. Even still, if you find difficult, as usual, we take the LCM. 4 1s are 1 1s are plus 4 1s are 1 1s are. Then here 1 means 1 by 1. 1 4s are 4 1s are 4. 1 plus 1, 2 minus 4 divided by 4. Now, here plus 2 minus 4 means the answer would be minus 2 divided by 4, because when the different signs, no, you take the difference and give the sign of the bigger number to the answer. Now, you can cancel 2 1s are 2 2s are, hence we get minus half, which is nothing but the right hand side. So, this is how we have to find out. So, you have to be careful about the corresponding radian measure, because each time we cannot go on converting the radian to degrees and find out. So it is 30 degree pi by 6, 45 pi by 4, 60 degree pi by 3. These are the one which we come across rather often in working out the problems. Next problem, 2 times sine square pi by 6 plus cosecant square pi by 6 into cos square of pi by 3. Cos square of pi by 3 should be equal to 3 by 2. So here it is a product and here it is a single term. But all of them we are having square terms here. So as usual, start with the left hand side. 2 into sine pi by 6. Already we are coming across the third time here. It is 1 by 2 the whole square, half the whole square, plus, see, sine pi by 6 cosecant, sine and cosecant, they are reciprocal ratios. Still you can refer to the table and write this is 2 square into cos pi by 3. Cos pi by 3, cos 60 has got the value half the whole square. If you simplify its arithmetical calculation, you can get the result. It is 2 into 1 by 4 plus 4 into 1 by 4, isn't it? 2 square and 1 by. So 4 and 4 they get cancelled. 2 1s are 2 2s. So what is remaining? 1 by 2 plus 1. Think directly, you can write here 1 and half. 1 and a half, when you take the LCM, without taking LCM directly you can write 1 and a half means 3 by 2. Even then you take the LCM. 2 1s are 1 1s are, 1 2s are 2 1s are, that is 3 by 2, which is nothing but the right hand side. So these such problems you can expect it usually for a 2-mark question. Okay. When you write the correct values here, for it, if it is asked for a 2-mark question, when you write the values here, correct values, you get the 1 mark for that one. And for the simplification part, you get the remaining mark. That is how usually marks are allotted for these problems. Now, let me move on to the next problem. Here, cot square pi by 6. Cot square pi by 6 plus secant pi by 3, secant pi by 3 plus 3 times tan square pi by 6. This should be equal to 6. So cot square pi by 6 plus secant pi by 3 plus 3 times tan square pi by 6 should be equal to 6. So we are getting a whole number in this problem. Start with the left hand side. See, cot pi by 6 means cot 30. Cot 30 means it is a reciprocal of tan 30. So it is root 3. Root 3 the whole square. See, we usually write only the first 3 because if you write all of them, it may be a little bit confusing. Generally we write. So when the tan value is known, for cot you can take the reciprocal. Now, secant pi by 3, secant 60 is the reciprocal of cos 60, that is 2, plus 3 into tan 30. Tan 30 means it is 1 by root 3 the whole square. Now, let me write it. Root 3 whole square means it is 3 and plus 2, and here root 3 whole square means it is 3 into 1 by 3. 3 and 3 they are cancelled. So 3 plus 2 plus 1, hence it is equal to 6, which is the right hand side. So this is how we have to solve the problem. And one more problem and I am concluding this session. Take on the next problem. It is 2 times sine square 45. Here also we are proving certain result. 2 times sine square of pi by 4 plus 2 times cos square of pi by 4 plus 2 times secant square of pi by 3. This should be equal to 10. This should be equal to 10. See, if you think a little bit, we can solve this problem in a simpler way. Look here, both of them are having 2 as a coefficient. If you take out 2 as coefficient from the left hand side, sin square pi by 4 plus cos square pi by 4. In today's session, I gave you the first identity. Sin square theta plus cos square theta is equal to 1. If you could think that about that one, you can simplify the problem in an easier way, in one step less. Otherwise, you just solve it, you looking at the values. So it is 1 by root 2 the whole square plus cos 45 means 1 by root 2 the whole square plus 2 into secant square pi by 3, secant square 30. Now secant square 60, pi by 3 means 60 degree. Secant 60 means you can see the value, it is the reciprocal of cos 60, that is 2. So 2 square. Now it is 2 into root 2 whole square means 1 by 2. 2 into root 2 whole square is again 1 by 2 plus 2 into 2 square is 4. Okay. Now 2 and 2 they get cancelled. Hence we have 1 plus 1 here, 4 2s are 8, 8 plus 1 9, 9 plus 1 10, which is the right hand side. So this is how you have to solve. Suppose you have taken 2 as common factor, instead of doing this one, 2 into 1. See here we have got 1 plus 1, 2 we have got here. 2 into 1 directly we could have written and we could have taken the value of the third ratio. So this is the method you adopt. So in today's lesson, we have revised whatever you had already learnt in the lower classes, trigonometric ratios and the identities and the standard values. Using the standard values, we have worked out some problems. In the coming session, I will be teaching you the new topic. You be careful, go through each and everything I explain in the class carefully, because whatever I teach from now onwards, from the next session onwards, they are important. You should know all the information and then only you can solve the problems. Thank you.